All right, good morning, everyone. And thanks for that introduction. Yes, I'm going to give you a brief update about the Exploration Science Strategy and Integration Office.
If folks do have.
Okay, so of course you've all talked with Joel Kearns earlier today. He is our Deputy Associate Administrator for Exploration, and Brad Bailey is his associate or assistant associate administrator for exploration. And this is our team at the bottom. These are our program executives and program scientists. And I did want to highlight, we added a new member to our team, Dr. Kenda Lynch. Very, very excited to have Kenda on board. Her background is in astrobiology, and she also has a lot of experience getting science instruments manifested onto ISS. So we're leveraging her experience getting science integrated into human exploration. And I cannot express how excited we are to have her on board to help with the vast amounts of work that our office is trying to execute. And that brings me to today's talk. So the tale of two campaigns. Of course, you've heard a lot already about Artemis and some about CLIPS. I'll give a little bit more information about both of these from the ESSIO perspective and the SMD perspective of how we're engaged in this process. ESSIO acts as a liaison between the Science Mission Directorate and, even more than that, the science communities at large. We represent all the divisions, the science divisions throughout SMD, so not just planetary. There's also a lot of other exciting science that is uniquely enabled by exploration at the moon, from the moon, and around the moon. So you heard a lot from Jake today about the strategy side of the house, so the architecture definition document, how the agency at large is working together to formulate a strategy to achieve the objectives that we have identified as what we want to achieve in our exploration of Moon to Mars. But I'll talk primarily today, of course, about Artemis and the Moon. But I also want to transition from that strategy to the implementation of what we SMD are doing actively right now to prepare for the near-term Artemis missions coming up. And also, of course, on the message today, highlighting how the science community can get involved in this process. So some of this is going to be a little bit of a repeat, or I don't want to say repeat, but a little bit of a more science perspective of the architecture definition document, especially the Moon to Mars objectives, where they came from. Jake referenced that I present this before about where these science objectives come from in the Moon to Mars objectives. You'll see a little bit of a tidbit of that today, of course, as well. So you are very familiar with the Origins, Worlds, and Life, the CADL of the Planetary and Astrobiology Division from the academies, the disciplines of science. But there are many other documents as well that we referenced when going through and making these, defining these objectives. So I just want to highlight that we start with the science. What science do we want to accomplish with the human exploration, but not only humans, also robotic exploration, as we venture farther into the solar system with humans. So highlighting again this traceability that Jake mentioned. On the left, you'll see box 22.2 from the OWL to CADL. These are the science themes that you, the community, came up with and told us that these were your highest priorities for human exploration of the moon. And we heard that, we listened, and these themes are not just applicable to the moon, they're also applicable across the solar system. And so we did tweak them, admittedly, a little bit to include Mars, but these are the foundation for the pillars of exploration that Jake mentioned before. Always going back to the science, going back to you to make sure that we're representing what the science community wants to accomplish. And so Jake talked about these as well, but these are the full suite of Moon to Mars objectives. And again, on the right side, you'll see those are all the science objectives that we're working to accomplish with the overarching architecture. And I want to stress these are not mission-specific objectives. They are architecture-wide. So they are very high level, intentionally so. These are intended to stand the test of time and allow us to make a mission by mission strategy to accomplish these in increments, but always striving to accomplish the objectives that we've set. And to do that, Jake already talked through, and so I don't have to go through all of the definitions, which I never intended to do anyway, but through the process. And so this is those high level objectives, we have to translate what that means. What do we need the architecture to be able to do? And so that's the different categories that Jake talked through. I wanted to talk through a little bit more specific from the science perspective, what that means. And there's a reason I'm highlighting it in so much detail, and I'll tell you that at the end. But so again, we've kind of talked about the LPS. So these are the lunar and planetary science objectives. LPS 1, this is really distilled down. This is understanding the ancient history of the solar system as recorded on the moon and Mars for us on moon. What does that mean? What do we need to accomplish to do that? What do we actually need to physically do in order to accomplish that objective? We need to explore geographically diverse sites, not only at the South Polar region of the moon, but also across the moon. There are key sites that are important for us to go get samples back and study these sites. We have to collect and document the samples on the surface as we're collecting them, importantly, while maintaining the science integrity of those samples. We have to return and curate those samples, again, while maintaining the science integrity of those samples. We also need to make in situ measurements, whether that means bringing instruments to the rocks that we want to analyze or bringing those samples back to analytical instruments on the surface. We need an architecture that enables us to accomplish that. So those are examples of the characteristics and needs you'll see. And then from there, we go to the use cases. We in headquarters are using these words all the time, like we're immersed in this language, but I respect that you're maybe coming to this a little fresh. So it's really kind of the nuances in some of these is a little hard to parse out. It's hard for us too, frankly, but the use cases, this is going into what is the concept of operations? What do we need the crew to do? What do we need robots to do in order to do this? So to collect the samples, we need crew excursions to locations distributed around landing sites. That means not just walking, we need driving, mobility, like Jake talked about. We need the collection of surface samples, we need collection of subsurface samples, all of those different components, those drive different functions of the architecture, different capabilities that we need the architecture to be able to address. And then functions, again, these are really important for us for defining the architecture, like Jake mentioned. So then we need to actually conduct the crew EVAs. We need to actually collect those samples. We need the tools and equipment that we need to maintain the science integrity of the samples. All of that is documented in this document. Okay, why am I talking about this so much? This is the primary part of the ADD that we have been investing in to update this year. This is going to be released later this year, and we really encourage, like, this is the opportunity for you to check our work. Please check our work, tell us what we're missing, and make sure that the gaps that we're identifying are the right gaps. We want to make sure that this is right before we start making investments down the line to accomplish these objectives. So your input is very valuable here. We'll talk about that more in a second as well. That's a lot on the strategy side. That's a really long-term planning, but there's a lot that we're doing, we SMD are doing right now to transition from that strategic thinking to the implementation. So these are the near-term Artemis missions that are coming up where active activities are ongoing. Artemis 2, of course, we selected our lead for lunar observing campaign. That's Dr. Kelsey Young, and they're actively training the crew in science. I think later this week they're actually going out in the field, picking up rocks. Even though these astronauts are not going to go on the surface of the moon, they are going to be given an opportunity to make observations of the moon, even from afar. And we want to help guide them in the observations that they can make that can contribute to science objectives. Also, we're learning how to do this and how to actually support a science or a science-driven mission for Artemis. Like, this is definitely a test mission, but we want to make sure that as we transition from test missions to science-driven missions, that we're ready and equipped to do that. Artemis 3, of course, we've selected our project scientist, Dr. Noah Petro, selected our geology team led by Dr. Brett Denevi, and then our candidates for crew deployed payloads, and we're working to assist in site selection and characterization. Artemis 4, we selected our project scientist, Dr. Barbara Cohen, and we're working on defining landing site criteria for science. And then upcoming, please be on the watch for upcoming solicitations for deployed and handheld instruments. And then Artemis 5, Jake just talked about LTV. The LTV instrument solicitation is coming soon. And there are other activities as well that are ongoing to help close gaps in the architecture to enable us to achieve our science. Okay, so how can you get involved? I've already talked about the ADD on the right, upper right. Your feedback on that is going to be very critical for us. So please do. This is a great way to engage on the process. And we do encourage you to coordinate your feedback through your AGs. I've mentioned leak here. Any AG that your comments are relevant, please be sure to funnel through if you're Mars focused MEPAG as well. But really, we want a community feedback from you to make sure that we're representing the science community, or that you're representing the science community when you bring your feedback to us. And then on the left, Sarah already talked about some of the exciting lunar surface science workshop topics that are upcoming. I did want to re-emphasize the points that she made on the content on these is designed around topics that are in discussion or planned. We know that is coming up between SMD and ESDMD, so this is a really great way to get your input into that process, not just in the review stage, but also in the formulation stage. The reports are used. So I also wanted to give a quick nod to LPI for all of the work that they help facilitate in planning the workshops, and then certainly to Survey for executing the virtual workshops. They're hugely successful because of the work that you put into it. So thank you very much for that support. And archiving the reports. This is where you can go to the reports. Sarah mentioned that at least one, I think there are 2 that are open for community comment right now. So please go ahead and take a look at those. I've included the websites. You can just web search for Lunar LSSW NASA reports and you'll find the site. It's very easy. But we do encourage participation in these discussions and the reports. I also want to thank everybody who's contributed so far, especially to the chairs. These are community representatives who come forward and help us with specific topics, arrange the workshops, and arrange the agenda. So we do have community input into the execution of these as well. And then on the bottom right, there are research opportunities upcoming for Artemis. The LTV instruments call is coming soon. I really promise it is. Artemis 4 deployed instruments and handheld instruments are to come. Okay, that was a lot on Artemis, but there's also a lot of exciting work happening with CLIPS as well. So here's our our typical moon map. You'll see 2 that are highlighted in green. Those are the 2 opportunities that missions that happened earlier this year, with intuitive machines successfully landing on the surface and performing science observations and operations on the lunar surface. So that was very exciting to be a part of. We're at the very start of reaping the fruits of the investments and the patience that we've been executing over the last few years. I know these are not as soon as we were hoping they would be, but they are coming, and they're coming rapidly now. And staying the course on this is very important. So we are really excited about the upcoming opportunities. We've spent quite a lot of time already this morning talking about Viper. Viper has been, of course, canceled and taken off of this moon map. We've already heard from Joel about a lot of this, so I don't want to repeat what we've already talked about, but I do want to underscore that there are upcoming opportunities to advance our understanding of lunar volatiles. And we've talked about how these are part of an evolving strategy for addressing those objectives. This is not meant to be replace Viper's exact observations and measurements that they were going to collect, but they are a part of that evolving strategy to accomplish that objective. So I'll talk more about IM2, the second intuitive machines landing that is expected later this year. But co-manifested with that is Trailblazer. It's going to hitch a ride with IM2 on its way to the moon to hunt for volatiles from orbit. Their CLIPS mobility as a service is a potential opportunity that we're looking to in the future. We're test running that with Lunar Vice, so we're very excited about demonstrating that capability with that exciting mission. And then we've already talked about Artemis Crew and LTV and the opportunities that those are going to impart into addressing the objectives we have for volatiles. I also wanted to highlight a couple of our international opportunities that are coming up. Prospect is an ESA ISRU demonstration that will be delivered to the surface via CLIPS. And they have a drill and a mass spectrometer, and we'll be drilling into the subsurface, not in a permanently shadowed region, but as close as we can get the lander safely to one. And then LUPEX is a JAXA rover delivered to the lunar surface by an Indian lander, and they will have a neutron spectrometer on board that will also be looking for volatiles. Okay, but back to the moon map. What's happening, what's coming up? So we have 2 deliveries, very excited. Later this year, Q4, calendar year 2024 is going to be a busy holiday season. But we have the first one is Prime 1. So Joel mentioned this earlier. It's the Trident drill and solo mass spectrometer that will be drilling into about a meter into the subsurface in the Shackleton connecting ridge near the South Pole. Also on that delivery, our Intuitive Machines was awarded 2 Space Technology Mission Directorate tipping points, which are kind of technology demonstration opportunities. The first is Nova Hopper. So that's a joint with IM and Arizona State. That hopper is going to hop several times on the surface, including into and out of a permanently shadowed region. And on that hopper is also a pyrometer that will be measuring temperature measurements, and also potentially a spectrometer that could be looking for volatiles as it's hopping. And then there's the Nokia rover that's going to be demonstrating the 4G comm system, which is very important for advancing the architecture going forward as well. And I've already mentioned Trailblazer. And then finally, the task order 19D. This is Firefly Aerospace's first landing attempt to the lunar surface. They're going to Mare Crisium to deliver quite a slew of instruments to the lunar surface, both technology demonstrations and science payloads to address some pretty exciting science goals, including, but not limited to, investigating the heat flow of the lunar interior with LISTER, studying plume surface interactions with SCALPs, X-ray images of the Earth's magnetosphere, and measuring the crustal electric and magnetic fields as well. So there's a lot of really exciting science that's coming out of this delivery. Stay tuned and let's cheer on Firefly Aerospace as they make their first attempt to stick the landing. And then the very last slide I have is on upcoming CLIPS-related solicitations. So PRISM standalone landing site agnostic, that solicitation, instrument solicitation is imminent. It's coming very soon. And then PRISM 4 is expected later this year. So there are a lot of opportunities to engage both on the hardware side and in the strategic thinking side for both Artemis and CLIPS. So please stay tuned and contribute. We look forward to your input. Thank you very much.